Hello there, Narek is here. Today I'm going to talk about the equality of two vectors, how to add two vectors, and of course the collinearity of two vectors in the coordinate system. Let's first start with, let's say we have two vectors. The first vector is u with the coordinates x and y. As for the second vector is v with the coordinates x prime, y prime. Now, in order to talk about equality of two vectors, it's very important to say that u will be equal to v if and only if we have x is equal to x prime and y is equal to y prime. So whenever you have x is equal to x prime, the abscissa is equal to the abscissa of the second vector, and the ordinate is equal to the ordinate of the second vector, you can simply say that these two vectors are equal. Now, how am I supposed to, if you want to take an example, this is, let's say, the vector u with its components 3, 2, while the vector v has the components -1 and 4. They are totally different, so I cannot say that u is equal to v. They should have the same components. Now, what about the sum or the addition? In case you're interested in the addition, you will have to say that u plus v is equal to a new vector, which we're going to call it w. Now, this vector w will have the components, so w will have the components x plus x prime and y plus y prime. It should have these components. Let's take an example. The previous case, so w is actually x plus x prime 3 plus -1, and the second component is 4, 2 plus 4, so it will be 2 and 6. So w will have the components 2, 6, or you can simply write it down as w2, 6. So this is how you find the addition of two vectors. Now, what about the multiplication? I will also talk about multiplication since we are mentioning about addition. So whenever you have a certain vector k times u is equal to a new vector, I'm going to call it z. This new vector z will have its component k times x and k times y. Alright, so from the previous example, u was equal to 3, 2. In case you want to calculate the components of your vector z, it will be, and we're multiplying, let's say, k by 3, so z will have the components 3 times 3, which is 9, and then 3 times 2, which is 6. So z will have the components 9, 6. Alright. Now, how about the collinearity of two vectors? How am I supposed to talk about the collinearity of two vectors? Very simple. We have the first vector we just mentioned was u, and it is defined by its components or the coordinates x and y, and the second vector v defined by x prime, y prime as coordinates. We can say that these two vectors have the same direction, or they are collinear, so they have the same direction if x times y prime is equal to x prime times y. Alright? Which means that u can be written as k times v. Whenever you have u is equal to k times v, it automatically means that u and v have the same direction. It's only a certain k, a constant k, which I'm using in order to multiply the first vector is k times the second vector, but the direction will remain the same. So, in case we're interested in k, we can say that x is equal to k times x prime. Similarly, y is equal to k times y prime. From this, I can deduce that k is equal to x over x prime and is equal to y over y prime. And once you do the cross multiplication, you will have x times y prime is equal to x prime times y. So this is the proof that you need, or you can simply use this formula, x y prime is equal to x prime times y, in order to say that these two vectors u and v have the same direction. I'm going to take an example. Let's say we have u, which is defined by 2, 3, and v is defined by 4, 6. In order to find out if u and v have the same direction or they are collinear, you can say 2 times 6 is equal to 12, 3 times 4 is equal to 12, so yes, in this case, u and v have the same direction. They are collinear. Now, what about the case where u is equal to, where u has the components 2, 3, and v has the components 1 and 4? Now, in this case, you will have 3 times 1 is 3, 2 times 4 is 8, so they have different values. X times y prime is not equal to x prime times y, so I cannot say that these two vectors have the same direction. Now the last part, which is again linked with the collinearity and linked with the same direction, in case I had 3 points and I want to demonstrate or prove that these 3 points are collinear, how am I supposed to do it? Let's say we have the point A with its components, the coordinates x, a, y, a. B has the components x, b, y, b, and C, x, c, y, c. In order to find out that a, b, and c are collinear, I should find a certain relation that says ab is equal to k times, let's say, ac. So from this I can deduce that I can use a similar formula previous to this, similar to the previous one. X times y prime is equal to x prime times y. So x is actually x of b minus x of a times y of c minus y of a is equal to x of c minus x of a times y of b minus y of a. So in order to find out that 3 points are collinear, you use this relation and you will be able to say that these 3 points are collinear. Now I'm going to take an example related to this case. Let's say we had A 3 over 2, 1 over 2, B 1 minus 1, C minus 1, and Y. Now the question is, how am I supposed to, for which value of y these 3 points A, B, and C will be collinear? You simply use the formula. So x of B minus x of A, 1 minus 3 over 2, times y of C minus y of A, so minus 1 minus 3 over 2, is equal to x of C is minus 1 minus 3 over 2, y of, excuse me, I will have to repeat it again because I made a mistake, so I'm going to repeat it again. So we have x of b 1 minus 3 over 2 times y of c is y minus y of a is 1 over 2 is equal to x of c is minus 1 minus 3 over 2, y of b is minus 1 minus 1 over 2. So I will have to arrange this. It's minus 1 over 2 times y minus 1 over 2 is equal to minus 5 over 2 times minus 3 over 2. I can, of course, arrange this. I will have minus 1 over 2 plus 1 over 4 is equal to 15 over 4. So minus 1 over 2y is equal to 14 over 4. Y is equal to minus 7. So for y is equal to minus 7, I will have the 3 points A, B, and C collinear. So this was the video where I talked about the equality of two vectors, the addition, multiplication, even collinearity and two vectors having the same direction, of course with the proof. So why not subscribe to my channel? You'll be notified whenever I upload new material, and I can also share with you my Instagram and Facebook account. Or why don't you leave a comment below? That's all for this time, and see you later.